Here? All right, great. Let's dive in. Today, we are talking about function as a service. Many of you might be wondering what on earth this has to do with functional programming, because this sounds very much like a DevOps talk. And I wouldn't blame you. It's not just because I don't have a whole lot of speakers, but there is a tie-in here. So if you will hang tight, we will get to where this has to do with functional programming, okay? Before I get started, I'd like a show of hands. Okay, how many of you are running servers on premise still? I say it like it's a bad thing. Okay, a couple back here. Your house. How many of you are doing infrastructure as a service? So you're running AWS or Microsoft Azure, Google Cloud Platform. Okay, a few more over here. How many of you are already doing function as a service? Or serverless, we'll throw that in too. Oh, you kind of, okay. So Scott's on the edge here. All right, this is cool. Okay, well, hopefully this talk is beneficial. I want to go back. Remember the time when you first got into programming. What did you like about programming? All right? What made you make that decision that this is what you wanted to do with your life? I remember very clearly I was young. And, whoa, let's move that over here. I was young, and my dad bought me this book, QBasic by Example. And he was a programmer. I liked computers. I was pretty young, and he said, I'll buy you this book and see what you do. I read that book cover to cover. I loved it. And I liked the idea of being able to build this world and then control the parameters and mess with it and see how things changed. It came with this version, Gorillaz. Does anybody remember this? Yes, okay. This is great. You're these two gorillas on the cityscape, and you're throwing a banana at each other, and a banana explodes on contact, and you get to control the angle and velocity of that banana. And they gave you the source code. So this is QBasic. You could get in there and change the source code, and I'd make the banana go like a rocket launcher and hitting the other one, or you can make the explosion much bigger, change the colors. Lots of fun. Okay, got really hooked on that. So when I was younger, I played this game. Who remembers this one? Dragon Warrior on the original NES. I still remember the theme song and a lot of the sound effects. It was great. So I played this game all the time. This is my first RPG. And I said, I want to write Dragon Warrior in QBasic. The problem was I didn't know how to actually do graphics programming, and I didn't have access to the internet. I just had this QBasic book. So this is what I did instead. It was a text-based adventure, very similar to Zork, where you have these different rooms that you go into, and there's a description, and then you get to do some sort of action. I want to pick up the object or whack the monster or whatever, okay? And I'll never forget, I went upstairs one day to my dad, and I was like, I'm trying to do this thing in code, and I don't know how to do it. And he's like, well, this is all you need to do. You need to read the file this way. You could use this data structure in memory, and that would allow your player to do X, Y, Z. And it hit me like a eureka moment. I was like, that is awesome. And I remember running down to my room, and I spent hours coding that up, and it worked, and it was just so cool. That feeling, you know what I'm talking about? That feeling when you solve a problem in code, and it just feels so cool. That's when I knew I wanted to be a programmer. It was all about the problem solving, okay? I really like that. Now, as a programmer, a professional programmer, I later learned the reality of life that came and hit me. And that is, there's a lot of not fun aspects to that. One of those, for me personally, I know it's the professional right thing to do, but I don't like learning new libraries and frameworks. You know why? It's because I didn't write those. And it's not me directly solving a problem. I can't do something. I need to be pragmatic about something, so I got to reach out to something else. And the problem is that we have all these DSLs that we got to go learn how they work. And you get this like spa page where you get this little code sample. It's so simple and easy. And when you actually try to implement it, it never works out that simple and easy. And before long, you're spending 80% of your time trying to figure out this library, and you're not actually writing your own code to solve the problem that you want to do, the fun part, in my opinion, okay? So it's super annoying, all right? In fact, it's the worst, okay, in my opinion, okay? Now, I know it's the right thing to do. I lead a team, and I have them use libraries and frameworks. It's the thing you got to do, right? One of those unnecessary evils, in my opinion. But software is not the only problem that this is in. There's also the infrastructure side of things, right? So I want my code to run somewhere, and that comes with its own burdens. So we got to decide, well, what are the build tools we're going to use for our language or our code? Dependencies. And how do those dependencies that have dependencies that have dependencies and the versions, how does that all work out? How do those get downloaded and refreshed and cached? Configuration. Man, how many configuration frameworks do we have and formats and languages? And how do we edit the configuration and deploy the configuration? And do we have to recompile our code because why did we do that? Deployment, orchestration, hosting. All right, you get the idea, right? Like, after a while, it becomes a job. And that's why you get paid good money to do it, because it's not just about writing that fun code, it's also about running software in the real world, on real servers, and being able to do something as quickly as you can, okay? You see where I'm leading here. Not that long ago, at a previous place of employment, this was when kind of cloud was still somewhat undecided on if that was a good idea or not, okay? And you had to have a really good relationship with your system admins if you wanted a new server. All right, so you wanted to be best friends, and sometimes it would resort to bribing. Because really, when you went to your system admin, you had the gatekeeper admin. Because you were saying, hey, I'd like to throw a party. Can I come into your living room and throw that party? And they're like, I don't know. I don't like that idea, all right? They spend all this time keeping their house nice, getting that environment in a good, stable place, and then you're going to sit in there and trash it. You're going to write files everywhere. You're going to use all the CPU and the memory, and it's just a headache to them because it's more work. The more access they give you, the more work it is to a traditional admin, okay? And cloud comes along, and it starts to fix some of those things. Because what we want our admins to do is to be enablers for the developers. That's where we really want to go. And so this is kind of this promise that we have with function as a service and with serverless technologies. Now, it's not perfect. We're going to spend some time talking about that today. There's a lot of hype here, and there's a lot of false promises. But remember, it wasn't that long ago that virtual machines were radical. I don't know about virtual machines. Cloud was radical. I don't know about cloud. Is that a good idea? Somebody else owns your stuff. And now it's funny because it's like I can't imagine being without cloud. My MacBook right now, I got a 2013 model. It is swelling. It's like sitting on a banana. Okay, the battery is bulging and it's getting ready to pop. I don't care if it pops because none of my actual files are on this machine. So I'm going to let it explode because I like the keyboard. And I'm going to get a new laptop and it's just no big deal, right? It's all in the cloud, okay? I now work at a company called Oseberg, and I've been there a while. When I first joined the company, we were very much in a startup stage. Things were young. We had what I would almost call just barely a prototype product. It was in the market, had some really good initial success, and we knew this was going to work. So I came in as one of the original developers, and we said, okay, we need to scale big time. So let's take this from prototype to real product, all right? Now, a startup, as you know, you're all about this. Okay, you got to go fast. You don't have a whole lot of time to gold plate a solution. So we said, okay, well, let's start with something simple just to get it out there. So we had a very traditional three-tier setup. You got your persistence, and that was, at the time, a single database instance. Lots of SQL going on in there. Probably a lot more logic than should have. We had a service, then in between an application. Okay, very traditional setup. And that got the sales team productive, so that was good, all right? Well then, I met with another engineer, and we were trying to plan and think, okay, so how do we take this to the next level? Because we really know we've got a huge volume of data, and a lot of processes are going to happen, so how do we go to the next level? And so there were two really critical trends that were happening in the industry: containers and microservices. These were really big at the time. And so we were looking at that and going, okay, we think this is going to solve a lot of our problems. And really, when we got started in this, it was bleeding edge. I mean, it was so bleeding edge. There was so much blood, okay? There was just bloodletting all over the place. And if you know me, I'm one of those guys, I don't like blood. I actually pass out. I went to a health check one time to get some insurance thing done at work, and I fell like a marble statue on the finger prick, okay? So, this was a big deal. But we got through it, and we said, okay, let's go in there. So we first started, we're going to get containers. We're going to do Docker, all right? So we brought Docker in. Docker is so cool because anything you can run in a Linux environment, you can essentially run in this nice little container. So you go back to that original idea of the sysadmin asking to have a party in his room. Now what that looks like is you're saying, hey, I'm renting a party van, and I'm just going to drive through your neighborhood, okay? Nobody's getting off the bus. We're just driving through your neighborhood. Is that okay? And he's like, yeah, sure, like it's not my house, all right? It's okay. So you can be in Docker, and you can just drive that party van through the neighborhood, and it's okay. All right, so Docker was huge for us, these containers. That makes deployments easier and so forth, all right? Well, then we come to microservices. That was a bigger change. Conversation kind of looked like this, you know, it's going to fix everything. This is going to be great. And then a year later, there was again so much blood. Okay, it was rough, but we got there. Okay, we look like this now. We got there, and we built some really cool tools around containers in our deployment. And then the AWS bill came in, and that was a shocker. All right, so for those of you who are using AWS, it looks so cheap when you look at their website, and then after a while, when you get microservices and you're running nodes all over the place and a bunch of instances, that gets exciting. So suddenly we realize, well, we got all these microservices, we have all these VMs, and we're leaving them on all the time. And you know, there's a lot of idle time that's happening, and we got to design for that, you know, because otherwise you're spending money that maybe you don't need to be spending. So that's kind of where we're coming into this serverless, a very long introduction to that. But I wanted to tell that story so that we have a framework for why this might be a big deal for us. And here's the tie-in to functional programming. When we built these microservices, we started out having very specific microservices. So we had a lot of them. I mean, we had so many microservices. Because when you go to that architecture, it's really hard knowing how to get that proper abstraction, how to break them out. You know, that's tricky. You know, do we have a microservice that does like this little thing or this like slightly bigger thing, or you know, what do you do about stateless versus stateful? And that's tough. And so we started out having some very fine-grained microservices, and we started looking at them at our architecture diagram, going, geez, a lot of these look like functions. If you really think about it, you know, we connected them all with Kafka, so a message queuing system, so we don't have to do like direct RESTful calls. They were decoupled in that sense. We started, man, they look like functions. You know, they just got your input, your output. You know, as functional programmers, we like pure functions, so we're not doing a lot of side effecting. It's idempotent. These are all good things. And so we said, well, what if we treated our architecture just like functions? And so we're just chaining these functions together, and we follow the same rules that a good functional programmer would use in their code, but just at a higher level of abstraction. And the good news is that other people were already starting to do this too, so a lot of the big companies. And this is where we're kind of coming now to this whole idea of function as a service, because other people saw this trend coming too. When you've abstracted to the level of container, so you have container as a service, so if you use like Kubernetes, for instance, that's kind of where they're coming from, containers first. And when you start saying that, you're like, well, even that, you know, you could probably abstract again on top of that. I just want to write the code that I care about. Remember, we were talking at the very beginning, I just want to write my business logic. Now, I don't necessarily need to worry about infrastructure so much, at least as a developer. I just want to be able to run it somewhere and run it at scale. So we get a whole bunch of input coming in. Well, I just want to run my function a whole lot. If I'm in my programming language, you know, I have threads and parallelization to my access. So why can't we do the same thing with servers? You know, this is Elasticsearch, Elastic Cloud. You know, it's really nice, this whole idea of I just give you my credit card and I have a slider. It's like, I need this many nodes, all right? Just take the money, I don't care, like just run it, right? Now this is more of, you know, this is not totally serverless, but the idea is there. That's really simple. There's only one control there that I'm moving around. So this is where we have incoming data events, some number of them, could be a lot, could be a little, a function in the middle with an input and output, and then some cluster. And I want that part in the middle. That's the part I want to control, my business logic. I got this deployable artifact. So I write my code, it conforms to a very simple API, then I just want to push it out there, then it's able to churn through this stuff. I don't care what the servers look like. I don't care what brand they are. I don't care how the disk stuff works. I don't care about that. I just wanted to run my code, all right? And I want to be able to scale up on demand. So that's kind of tricky. When you start designing your code with good functional principles and then you start using Like maybe, for instance, depending on what kind of architecture you have, you start thinking about like events and event messaging and folding and things like that. It's really easy because now I got these bunch of stateless services that can take any number of input, and as long as the thing that is feeding those doesn't do a bunch of duplication, I'm okay. All right, so I don't want that to be my problem. I didn't make this graphic, but I thought it was really helpful in explaining the abstraction. We first start out with infrastructure as a service, and so we go from I'm hosting a server on premise to now I'm using like AWS or something where somebody else manages the virtual machine, and I'm paying for some number of CPUs and memory. And then you got platform as a service where now the operating system and the runtime, so kind of like a Heroku or Cloud Foundry, and then you get to function as a service. The entire stack now is abstracted out, and I just provide the actual function itself. So let's talk about service providers for a minute. The good news is that when this first happened, we kind of had these four bigs. The first one I remember hearing about was AWS Lambda. Okay, that was the first one that really hit that enterprise market. And I don't know if some of these other guys were doing it earlier, they might have been, but I remember hearing about AWS Lambda first. And you also, of course, pretty soon after you got Microsoft Azure Functions, Google Cloud Functions, and IBM even has an implementation. So I'm not going to go into depth on each one of these. What I really want to do is spark your curiosity, and you can go kind of look at the semantics of each. But let's at least look at AWS Lambda just to kind of have a framework for what this might look like. So there's really two core concerns that you have. The deployable function, and so you can pick from, it used to be a limited set of languages, but now they have support for containers. So really anything that you can containerize, you can deploy now, which is really cool. And then what you need to specify is the trigger of when your function is going to run. So how do you know that your function is going to be invoked? And with AWS Lambda, of course, the AWS, they love to keep you kind of in that ecosystem. So they will have a lot of integrations with their products. So if you upload a file to S3, that can trigger one of your functions to run, and it gets a handle to that file, and it can process it, and then move on. Or you can use like a DynamoDB data update, or app event triggers, an API gateway. The API gateway, that's push-based. So if you're like on a mobile app or a web page, you can submit an HTTP post request and hit one of these endpoints, and that would trigger a function as well. In terms of constraints, all you have to provide is the amount of available memory for each instance. So today, it's 128 meg to 3 gigabytes, and then you have your AWS identity. So that kind of handles your security and permissions. And everything else is controlled. You don't have control over the amount of CPU. That's proportional to the memory. So if you need more CPU, you might increase your memory, and it has more kind of wiggle room to play with. And then a network and disk, those are just completely abstracted away from you. So that could be a good or bad thing, right? By going to this level of abstraction, we've said, well, we've made it really easy to just publish a function out there and have it run. But by doing that, I'm also giving up control. And that may or may not work for what you're doing. So that's one of the things you have to consider is how much control are you willing to relinquish? So you might have some problems you're trying to solve where you're like, yeah, I just want that to run. And there might be others where you're like, I really need to have control over where this is happening and what kind of resources it has access to. In terms of the pricing, the way they typically do it is there's a flat rate for each request to the function. It's just a fraction of a cent. And then the actual runtime of your function. So those two together kind of equate to your price. And you can go look at the price breakdown. It has to do with how much memory is allocated to and stuff like that. So there's a little formula online you can look at to see how that comes down. And so in terms of the API, you have these three components. You have the actual function handler itself, and then you're given an event object. So that's whatever is coming in as input. And so that might be the handle to an S3 file, could be something that came from a push-based API, whatever that is, and then a context object, which is like your configuration and some of your runtime parameters. All right, sounds amazing, right? Yeah, so there's a lot of really good things here, but there's also some cons as well. So first off, the good things, infrastructure is not your problem. All right, that's done by them. You just run your code and you're good. You stick to the problem at hand. Also, you might have reduced cost because you're not paying for that idle time. Whenever those services are not getting run, they shut down and you're not charged for that. So I think Amazon charges, I believe it's they round to the 100 millisecond, and so you're not paying for any of that idle time. Auto scaling is free, which is really cool. So if you get a whole lot of load and a whole lot of back pressure on whatever your event stream is, it will automatically just spin up new instances for you and chew through that. And so, you could say, well, it's actually cheaper for me to just give a lot of instances this massive amount of memory, and then it can just plow through that incoming stream really fast, and then it all shuts down in a very short amount of time. So you kind of play with how some of that works. And also there's just less stuff. Because you're not spending time writing your own infrastructure scripts, there's just less things you have to maintain and do. Now, when we got into this, we didn't start with function as a service because it was so new at the time, so we were writing a lot of our own. And now we have a whole lot of scripts that we've written to do our own infrastructure. But that's all things we have to maintain. And so there's a lot of work there. On the flip side, managing state can be tricky. That does not come for free because these work best when they're stateless. So you're more of a pass-through. So something comes in, you transform it or do something, and then you send out your output. Now you've got to be kind of concerned, like if you need state somewhere, you have to think about how you're going to interact with that in a way that is going to work with one of these functions. So if you're in the Amazon ecosystem, that might mean you're interacting with other AWS services. Or if you're on something like Kubernetes or something like that, then you can have a few more options there. Also, high latency. Because these are invoked on demand, you might get what's called a cold start. So whenever a request comes in, it goes through this lookup where it finds your registered code, your deployed artifact. It actually creates a container behind the scenes, puts that in cache, and it's running it. And then that'll start feeding through your data. Well, after a while, when that container is not being used, it's going to garbage collect that, and so it'll throw the container away. So whenever the next request comes in, you're going to have a cold start, and it might take a few seconds for that latency for it to fire up and get initiated again. You also might have what's called the noisy neighbor, where you've got you don't know where these are running, and so you have no control over what anybody else is doing in that ecosystem. So they might be doing something that's really intense, and the way that it's breaking it out on those servers, you might be on a server that's particularly pegged. Now, it's Amazon's job, or whoever the provider is, to figure out how to reduce that from happening, but it's not perfect, and there's still a lot of work to be done. Also, you get limited runtime. In particular with Amazon, I think nowadays it's 15 minutes is how long a function can run. It used to be just 5 minutes. If you use something like Kubernetes with FaaS, that is a product that provides function as a service on top of Kubernetes. It's unlimited. So there are other providers that are providing alternative ways if you need to get around those kind of limitations. Now, why might you use function as a service? Because I probably wouldn't encourage you necessarily to go and just put all your code out as a function on one of these things and let it go. But there are some really cool use cases. So for instance, if you have an Alexa, buy creamed corn, confirm. See how that goes. So if you have an Alexa device, Alexa's using serverless behind the scenes. So whenever you send off an Alexa command, that will trigger just a function, a Lambda function, and then it goes and does it. Image conversion, so maybe you upload an image somewhere and you want them to automatically go through a conversion or compression process. That can happen kind of just through a Lambda function. Recently, they've been talking about doing a lot more ETL. And this is what I thought was kind of interesting, where you have data that comes in on a message queue, and then you want to start processing that in some kind of data pipeline. You can chain these functions together. So if you're using queues, you could say, okay, it comes in on a queue, and then this event or this function is going to trigger on that particular incoming queue. It does like some ETL logic, pushes that out to the next queue, and then some other function picks that up. And before long, you kind of have this like chain effect of data that's flowing through this ETL. So that's pretty cool. I have to admit, I have not actually tried that yet, so I don't know what the cost looks like of doing something like that versus more of a traditional approach where you're using some other ETL tool. But that's something I think would be pretty interesting. All right, so that's kind of that. Today, I just wanted to kind of inspire you guys about what this is and what's out there. Does anybody have any questions? Yes, Aaron. Yeah, I actually don't know how to answer that. Huh? Oh yeah, Aaron was saying that it makes local development tricky because you have to deploy it out there, but what do you use to develop it locally? I don't know. I don't have enough experience with Lambda in particular to tell you. I know that they have a SAM, which is a toolkit for building these things. And so that is supposed to be an API that helps you, package and deploy out. So I would imagine if you're using it with a container, you can do just your normal container development, do all your unit tests, integration tests with that, and then deploy the, like a Docker container up through that service. But yeah, that's a good question. Anybody else? That orchestrate, have I found any tools that orchestrate? Oh, yeah, that's a good question. I don't know. I tend to always think of development in terms of containers now. So we're very much like a container first type place. So usually what we do is we'll develop a service in a container and then deploy that as your unit. And so yeah, beyond that, don't have a whole lot recommendations. No. Yeah. Yeah, so what we typically do is we'll develop the code locally on our machine, and then we will package that in a container. And so with Docker, for instance, you can just run Docker containers locally on your machine. So we have scripts that will package the code that we build into Docker containers, and our build tools will do that too as well. And then once that Docker image is built with the compiled artifacts, then we push that up to a remote server. So that allows us to do local development, and then we can use like Docker Compose to try running a whole bunch of containers all at once, and then we can do integration tests between the containers. Does that answer your question? Okay. Yes, and some IDs are getting better support of that. I know like VS Code has things different integrations that are really nice. And so that's becoming more of a thing where you have to do less scripting yourself, and it's now built into the IDE. And so there are plugins, as far as I understand, especially when you work with these things, there are plugins into various IDEs that will integrate. There is a project I mentioned called FaaS, and that's the one that is deployed on top of Kubernetes. And that one has Git plugins. And so you can actually use just like your Git push, and then it integrates with that to handle the packaging and deployment into that system. We're not actually using Lambda yet. Yeah, so this is more R&D for us. We do most of our container management ourselves at the moment. Mm-hmm. All right, cool. Well, thank you. Appreciate it.